Welcome to Semantic Brain. In this video, we will cover how AI is radically reshaping enterprise applications and digital channels. We will cover the underlying trends as well as present a novel approach. If we look at computing pre-ChatGPT, tasks could be categorized into two areas. One was transactions and the other was analytics. Transactions was about getting things done. These were simple tasks, but computers excelled at performing these tasks accurately, very fast, very cost effectively, and at scale. On the other hand, there was analytics, which was big picture questions, deciding what, when, why, where, how, and computing was not really very good at this. There was also a third category that kind of fell in between. These were new types of interactions. These include things like chatbots, notifications, and topic prediction. The introduction of LLMs and generative AI meant there was a lot more new use cases in areas like content generation and a lot of language-driven capabilities. But LLMs did have their issues. They weren't good at quantitative analysis. Even the traditional AI, which was really designed for quantitative analysis, did not return an ROI on 70% of instances. Speed and cost of LLMs were a problem. If the LLMs were trained on generally available data on the internet, they did not understand your business very well. And there was also security and IP risks, especially you didn't want to train the LLM vendor to compete you out of your business. But LLMs have been getting better and better. One of the common ways to track progress is the LLM leaderboard. And they basically use ELO rating, which is used in chess and a number of other games. And as you can see, many LLMs have over 1,000 ELO scores. So they're very good at generalist type of tasks. And they're continuously getting better. But the larger LLMs and some of the newer LLMs are actually quite a bit more expensive. So from a cost perspective, it doesn't always make sense to use the latest and greatest LLM. Business intelligence and traditional AI also have issues. BI is a great tool for monitoring and keeping track of what happens. It produces great reports that generally explain what already happened. In terms of descriptive analytics, where simple statistics was used, it was mainly used to identify correlation. These tools did not enable or support executives in their decision making, and there were no language capabilities. With traditional AI, however, we've added predictive, which is forecasting, diagnostic, troubleshooting, and prescriptive, optimizing analytics capabilities. However, 70% of these AI projects did not provide a return on investment. The key reasons were insufficient data, data quality, model accuracy, and explainability. These are on the data and model side. On the business side, there were lack of qualified staff, cost of staff, project and compute cost issues. Software development is rapidly improving due to LLMs. Just a couple of weeks ago, the first software engineer, Devin AI, was released. And LLMs have themselves been getting better. The GPT-4 that was released in May 2023 had a first pass score of 76.8%. Claude 3 Opus, released in March 2024, had a first pass score of 84.9%. However, that improvement pales in comparison when you combine LLMs with other frameworks. The best one so far, Agent Coder, has a first pass score of 96.3%. This is only going to get better. I personally have been using AI for Python code generation, SQL query generation, and Cypher query generation. And I easily see software developer productivity increasing at least threefold within 3 years, and probably tenfold within 5 years. Unlike chatbots, AI has a very good understanding of the development and execution environment. Therefore, AI generating code is guaranteed to succeed. It is time to rethink computing. The current approach right now is to pass everything through LLMs and use traditional AI and conventional graphs to address weaknesses. This approach is costly and results in slower output, and often it can actually be inferior as well. Semantic Brain went back to the drawing board. We went to first principles, and we came up with a parallel architecture where there's traditional AI, conventional graphs, and LLM, all working parallelly. And we added BizML and semantic graph to improve traditional AI and conventional graphs capabilities, resulting in better, faster, and cheaper solutions. The way BizML works is that if you look at machine learning as a process, you start with inputs, you clean up those inputs and they're fed in as features, and you apply AutoML or ML and outcomes recommendations. What we were able to do is come up with general feature engineering and feature selection, general proprietary feature engineering and feature selections capabilities that significantly improved signal and reduced noise, therefore increasing the accuracy by 5 to 20% or reducing the error rate by 10 to 50%. This approach also requires much less data. When we applied it, and actually this is a quantitative approach that we applied to language, and in this case the language is translated into a vector space of 768 floating point values, but we translated into language, and it was an imbalanced data set which gave 90% plus accuracy on the non-hallucinations, but less than 20% accuracy on the hallucinations. So there were much less hallucination data there. This is how you ended up with a 79% accuracy, which looks good, but an F1 score of 0.3%, of 0.3. But once we applied BizML, we were able to get it to detect more than 50% of the hallucinations. So it reduced the error rate by 50%. And this worked on a very tiny data set. And this case study is not just an example of how it can improve the accuracy of a data set, but more importantly, with very little data, you can figure out whether it's possible to improve something which very early on, which is quite useful. And when we applied it to marketing, that increased accuracy gave some really impressive results. Again, here we used it with both language and quantitative data. It was used to pick keywords and negative keywords, and also bid price and budget. And it essentially gave, in India, it gave a 54-fold increase for a $1,640 budget. In the US, for a $1,000 budget, it gave a 9.7-fold increase in the number of conversions. The very first attempt of using BizML or internal simulation that we used BizML for was in trading. And this was just a simulation versus the others were real-world examples. This was a simulation. And in this simulation, we combined long portfolios and long positions and short positions to create a portfolio that actually had a Sharpe ratio, which was a risk-adjusted return, almost six-fold, more than five-fold that of S&P 500. And as you can see, with BizML, we were able to identify, when we predicted these stocks will go up, 70% of the stocks that we predicted will go up, went up, and that's quite significant. What is even more significant is that the magnitude of the movement here was much higher in the direction that we predicted than the other way around. So that's an example of how it can be used in total in quant-only solutions. But also this one was a much more complex, although it was limited to quant, it was much more complex, and reducing or improving the signal-to-noise ratio was a very significant challenge. What semantic graph then does is it takes that quant knowledge and integrates with the language capabilities. LLMs and with RAG, they perform semantic search, Q&A, chatbot, content and generation. This is all well known throughout the industry. But what we did was essentially use graphs, and graphs are great at modeling the real domain. I mean, tables don't look like the real domain, versus graphs can really model the real world much better. And with BizML, we identify signals that we incorporated into analytics, and then we can use graphs to augment the language processing capabilities as well. So now, with semantic graph and BizML, we were able to perform higher order tasks and super intelligent workflows. And not only that, when we start, after we take this parallel architecture and place enough emphasis on the quant stuff and the graph stuff, you ended up enabling new types of use cases. So the prediction capability enables more accurate notifications. And also, it enables better topic prediction. On the other hand, once we add like common capabilities like specialized or constraint agents, you also increase higher order tasks and improve the ability to increase the intelligence of your workflows, which can be user or system initiated. So what are the real world applications? So if you really look at the opportunity space, it can be in three areas. One is quant optimization. Again, you can take language and quantify it, and you can optimize it. And some of the big examples here is looking at ad optimization, website content optimization, or search engine optimization, as well as optimizing the user experience across web and mobile apps. The other area uh, is definitely language analysis and generation, and here you can take like semantic graph to improve results. And one of the best examples is information security and privacy, where more and more software will need to make sure that it's actually secure and it's compliant. And this is one area that will be important. The third area is essentially combining both quant and language, and this may be the highest value add. And some examples here is identifying quant signals, saying, okay, based on these quant signals, we predict the stock will go up or down, and the magnitude of change would be higher than this or lower than this. And then look at any documents like security filings and news articles to kind of support or invalidate this hypothesis. The other way is also to look at 8K release or a news event coming in, and then do a quantitative analysis based on that to figure out how this might actually impact the price movement of the stock. It doesn't have to be financial, but that's one area. It could be similar opportunities in medicine or other areas as well. So from a company perspective, what can you do? So I believe the best place to start would be to identify the workflows and tasks that you have, and identify if those tasks and workflows are quant in nature, they have language only, or both quant and language requirements. And also in terms of type of activity, is it transactional? Is it analytics? Is it content generation? Is it interaction? And once you have a list of those workflows and tasks identified, then you can specify or prioritize and or rank and prioritize and select which projects you want to work in. I feel one of the best areas to focus on is digital journey optimization, partly because software development itself is going to go through a revolution, which is going to change this space. And the other part is because with digital channels, you have a lot of information, and more business transactions are happening over the digital channels. So you really have the opportunity to understand the customer really, really well, and then develop the best products and services for them, and then optimize the cost of delivering those products and services. And especially in the B2C space. So in and from an enterprise perspective, we are confident that you can achieve super intelligence at the task level and workflow levels. We're not talking about super intelligence that will surpass human intelligence, but combining AI and humans to deliver super intelligence at the task and workflow levels is very much feasible. And we have developed a formula which basically says that it is an improvement in terms of quantity and quality, and the multiplier of the quantity improvement and the quality improvement has to be greater than a factor of 10. And that's kind of how we quantify super intelligence. So you can make a significant difference in how you execute tasks and workflows within the company. As far as individuals are concerned, yes, there is the concern that traditional enterprise application development jobs are going to dwindle because software developer productivity is going to go up. Um, that's just reality. But at the same time, um, smaller companies who wouldn't do custom software development, couldn't afford to have AI, will now have software and AI, which means more opportunities. There will be a lot more high performance computing. There's already a lot of high performance computing working on LLM and generative AI and other AI activities, and this is just growing, already going through significant growth, and that growth is going to continue because there will be more opportunities there. And edge computing, whether it's smartphones, tablets, PCs, there'll be a lot more opportunities to optimize semiconductors, the hardware, the low-level software, and even the applications. How do you incorporate AI into these applications on these edge computing devices? That's important. So that's going to take off as well. One of the biggest areas that's going to make a big difference in terms of career opportunities and also human life is in scientific computing. Medical healthcare is going to be the biggest beneficiary of this. Significant opportunities in medicine, pharma, biomedical devices. AI was used to discover the first antibiotic in 60 years. There's a lot of new drug development, vaccine development that's going on with AI. This will be a huge opportunity space. Material sciences and energy will also be a big opportunity space. AI was used to develop a battery that used 70% less lithium, and this significantly reduces the cost and benefits the environment as well. So similar opportunities, so there's lots of opportunities that will be emerging, and that will likely be more lucrative for the techies. And really, so in conclusion, to benefit from this trend, don't think it's just ChatGPT or Gen AI or language. You really need to think quantitative and language. And in terms of how people use it, it's not just about user prompting AI. It should also about AI alerting the user of something that's worth paying attention to. And that's going to happen even more. And the other step above that is really people collaborating, multiple people working together, and AI really supercharging that collaboration, taking your organization, your enterprise to a whole new level. Thank you for taking the time to listening to me. I'll provide the contact info below. Definitely feel free to reach out. Thank you again. Have a great day.